ties to harness kinetic energy harvesting in shopping mall in Ghana. This is the outline of the study or the paper, looking at the background of the study, the method adopted, the findings, the conclusion, and implication. Looking at on a global context and innovation focus, renewable energy demand is on rise due to climate concern and global warming. However, kinetic energy harvesting, especially from perspective of human movement, have offer enormous opportunity for engaging in alternative energy generation other than solar and wind power as a renewable energy. In Europe and part of Africa, such as Nigeria, kinetic ties are used in public and sports space in order to power lightning and small devices. And this in itself is demonstrating the concept of feasibility and public appealing. Looking at the Ghana context, the study have observed that Ghana is exploring hybrid method or model, which is combining solar and kinetic energy system, showing growing regional interest in such technology. Despite high and consistent foot traffic in Ghana malls, there is a significant lack of empirical research focusing on deployment, performance, cost, and public acceptance of piezoelectric energy harvesting techniques in this given setting. Therefore, this study gears towards addressing the void by evaluating the technical and economic feasibility of using kinetic ties in mall, aiming to inform sustainable energy strategies in Ghana and other urban within Africa. The methodology adopted in this study, a combination of fieldwork, sensor measurement, and computation modeling was adopted. And now this data was collected in Accra Mall and West Hill Mall. These are one of the biggest malls in Ghana. In the sense that kinetic ties were installed in high traffic zones. Energy meters recorded daily and peak output in the real time over 3 months were recorded. And as well, stimulation inputs were enriched by estimating average body weight and working patterns within the context. As such, MATLAB-based stimulation was developed to mimic the real-world pedestrian activity on piezoelectric. And these simulation have the purpose to estimate the voltage output, calculate the daily and the peak energy yield for various mall sections. And in order to enable risk-free energy performance forecasting before full-scale installation. Result: assessing the day type and food for volume. Kinetic ties energy output fluctuate with pedestrian volume, showing apparent variation between weekdays and weekends. During the weekdays, a 10 square meter section generates around 1.95 kilowatt daily with roughly 3,000 steps. On weekend, when foot traffic doubled up to 6,000, output rose to 3.86 kWh. This result underscore how food for density directly influence energy yield, highlighting the strategic benefit of placing the tiles in an area with high and consistent weekend activities. On the traffic time and daily usage pattern, when comparing different usage windows, the simulation revealed that concentrated pedestrian activity during the peak time, such as lunchtime and late afternoon, lead a notable energy output to that of 2.91 kilowatt per a day. In contrast, tiles active only in the evening in terms of after 6 p.m. produce just 1.32 kilowatt daily. In conclusion, the kinetic energy harvesting system are technically and financially viable and feasible for high traffic more zone in Ghana. Stimulated output is 3.4 kilowatt per day in terms of 10 square meter at entrance. Observed output shows 3.4 kilowatt per day, demonstrating a strong model accuracy, scalability potential. Doubling tile area up to 20 square meter in a busy zone, nearly double energy output to 6.90 kWh per day. However, low traffic zones offer poor returns, highlighting the need for targeted deployment. On energy saving, on annual savings between 584 to 1,582 Ghana cedis are likely to be saved on this given aspect. Thank you very much for your time. I really appreciate